welcome back. Today I would like to talk a little bit more on information measure. Up to now we only defined the channel entropy Hx is basically given by a summation of x minus px log px. And notice also that we are only considering a discrete random variable. Of course, if your random variable is continuous, you expect the amount of information there is infinite. So we need to have a different definition. We will talk about that later on. Of course, one thing that we can immediately extend is we consider like more than one variable, let's say hxy. Immediate question is that what should this hxy be related to, like hx and hy? So we think of that naively. We probably will believe that hxy is just equal to hx plus hy, but it's not as simple as so in general, because there may be some correlation between x and y, so that some information will be less than hx plus hy, because if you already know x, then you know a little bit less, so that you need to know the total x and y. So actually in general we will have something like this: hxy will be less than hx plus hy. But in any way, like hxy, we can just write this using the channel entropy definition, just thinking like xy is a joint variable. So we can think of this as one variable. Then hxy is just equal to minus some xy pxy log pxy. And by train rule, I can write pxy is equal to px and py given x. So therefore I have log px py given x here, pxy so of course log a times b is equal to log a plus log b, so I can write log px plus, let me just write two summation here just to see it more easily. So this will be minus here, and know that like y here, in terms of y here, log px is really a constant, so we can kind of like pull out px out of the summation of y here, and sorry, I mean log px here. We can pull log px, and sum over y of pxy is just px, right? We have marginalized y basically, so this is just px. So, and this is just the entropy of x, and I have another term here, is just this guy. I can also write this as like something like px p sum over y py I guess it's better I put plus here, sum over y minus py given x log py given x. So we can see this guy is very much similar to the channel entropy definition at the beginning here. And we can really think of this as hy given small x, right? We can think of like, this is basically the channel entropy of y, given that when we have y is like kind of, you can think of y is a distribution tuned by a parameter small x here. So for different small x, you have a different distribution of y, and this hy given small x here is basically the amount of information of y when the parameter that tune the distribution of x, distribution of y is small x here. And this sum over x px. And I will define this thing here is basically when we have a distribution of x, that basically the parameter that control the distribution of y, this x here, itself is a random variable, and we have a distribution of x. When we average over the amount of information of y, given that we have a distribution of x, then laterally we can define this as like hy given x. This is like we will call this a conditional entropy of y given x. So what we can see is that like hxy now is really equal to hx plus hy given x. So intuitively, you can just think of like hy given x is the amount of information of y, given that x is already known. And also like again, hy given x is like an average of hy given small x over the distribution of x.